Greetings. Okay, so in this video we're going to look at travel graphs under kinematics mathematics. So with me is a question here which we're going to focus on. So the question says the figure below shows the motion of a particle. Then the figure is representing the speed time graph. So we have a particle moving from rest, then it covered a maximum speed of 30 meters per second. It moved with this speed for 15 seconds. Then it started retardating in the space of another 15 seconds. So the question says calculate the acceleration of the particle in the first 20 seconds. So in order for us to calculate the acceleration, we first need to know the physical quantities that are represented under a speed time graph, and we need to identify the gradient of a speed time graph and what it represents. So what does the physical quantity represented by the speed time graph, what is it? What does it represent? The gradient of a speed time graph. So the gradient of a speed time graph, it represents acceleration. Now what is this acceleration that we are talking about? So acceleration is simply the rate of change of speed with reference to time. If the speed given, it is in a specified direction, it is called velocity. So therefore acceleration can simply be defined as the rate of change of velocity with time, or the rate of change of speed with time. But when we talk about rate, we're already considering the time interval. So we can simply say the rate of change of speed, or we can say the rate of change of velocity. Without wasting much time, let us begin by calculating question A, which says calculate the acceleration of the particle in the first 20 seconds. So to calculate the acceleration, we are said it is the rate of change of speed with time. So we say acceleration equal to the final speed which I'm going to represent with theta v. So the final speed v minus the initial speed u divided by time. So this is the formula we use to calculate the acceleration. So now, having looked at this, what have we been given? What data do we have? So we know that the final speed here is 30 meters per second. So we are going to represent that. So we say 30 minus 0 meters per second divided by time, which is 20. So why is 0? So it is so because the object started moving from rest. So the rest position here, the initial 0. So 30 minus 0, we just get 30. Divide 20, that is going to give us 1.5. So this will be 1.5 meters per second squared. Now, we might ask, why is it so? Why is it 1.5 meters per second squared? Oh yes, it is 1.5 meters per second squared because we are dealing with acceleration. Acceleration is measured in meters per second squared. So this becomes our acceleration for the first part, question A. We now go to B. B, it is requesting us to calculate the acceleration of the particle in the 40th second. So if you consider here, after the 35th second, the object has started retardating. So the object was retardating, meaning that it was reducing in speed. So now the reduction in speed, it is opposing acceleration. So therefore acceleration here becomes a negative. So if we say retardation, that is positive, but opposite of retardation, that is acceleration. So they are the opposite of the other. So when the object is retardating, it carries a negative sign. The acceleration becomes negative because that is retardating or deceleration. It is reducing in speed. Okay, but here they are saying calculate the acceleration. So we expect a negative value. So therefore, we calculate our acceleration by using the same equation. So the final minus the initial divided by time. So now, what is going to be our final in this case? So the final, it's 0. The object has gone back to rest. So we'll say our acceleration becomes, so the final velocity, we are saying that is going to be 0 because the object has gone to rest. Then the initial velocity, now before it went to rest, it was traveling at what speed? Okay, so it was traveling at 30 meters per second. And then what is the time? So you can see here that it's after 35 seconds to 50 that the object was retardating. So 50 minus 35, we get 15. So 30 divide 15, but remember that 0 minus 30 is a negative. So 30 divide 15, which is a 2. So we're going to have 2 meters per second squared. So why the negative? Because the object is doing what? Is retardating. So this is going to be our deceleration, our retardation, our negative acceleration, because the object, it was reducing in speed. We go to question C. Question C, we are calculating the distance moved by the object. So in order for us to calculate the distance traveled by the particle after the distance traveled by the particle after the 35 seconds. Okay, before I even go to C, there's a point that I would want you to note. We said that we need to calculate the acceleration of the particle in the 40th second. Yes, in order for us to do so, we're looking at the space from 40 to 35, 35 to 40. So since the gradient is just the same, the acceleration is going to be the same everywhere. The acceleration will be the same. So even if we get 50 and 35, it will still be the same. Or we get 40 and 35, we're still going to get the same. So the acceleration is just the same throughout because the gradient is constant. So, but remember, we're looking at we moved from 30 to the initial. So because we don't know the actual speed at the 40th second, but because the gradient is just the same, so we use the 50. So 50 minus 35, that's how I had obtained the 15. So I didn't use the 40 itself because I don't know what was the actual speed at the 40th second. So intelligently, strategically, we used what? We used the 50th second and the 35th second to obtain the acceleration of the particle at the 40th second. Okay, so now I proceed with the distance traveled by the object. So in order to find the distance traveled by the object of the particle, we simply use the area under the graph. So since this is a graph, finding the area given on the specified divisions, we obtain the distance traveled by the object. So in this case, we want the distance traveled by the particle after 35th second. So from the 35th second to the 50th second, we look at the shape that has been made by the movement of the particle. Of course, that is a triangle. So therefore, we just need to calculate the area of the triangle. So the moment we get the area of the triangle, that automatically becomes our distance. But the difference is going to be the units. So therefore, we say area of a right-angled triangle as it is half base height. Half base height. So half multiplied by the base multiplied by height. So this becomes a formula for the area of a right-angled triangle. Then, so half of what? What is the base? So the base, it is just 50 minus 35, which is 15. So half of that is 0.5. So 0.5 multiplied by 15 multiplied by the height. So from the rest position here up to the maximum speed, which is 30. So half of 30 is 15. 15 multiplied by 15, that is 225. So 225 meters per second squared, that is the area. Meters per second squared. Okay, so meter squared, sorry, not per second, but meter squared. My mind is still calculating acceleration. Okay, so this is the area, but are we calculating area? No, we're calculating the distance. So therefore we say the distance traveled by the object after 35 seconds is going to be, so distance equals to what? 225. 25 meters, just meters, not meters squared, but just meters. Okay, so this is how we're supposed to calculate all the questions that we are supposed to be, that we are required to calculate, finding the acceleration in the first 20 seconds, finding the acceleration in the 40th second, and also calculating the distance traveled by the particle after the 35th second. I really appreciate your time watching this particular video. Don't forget to like and share